Good evening, everyone. My name is Tushar, and I'm going to explain you about the essay attributed language. So, coming to the definition of essay attributed language, essay attributed grammars is a part of the attribute grammars. Generally, attribute grammars have two types: the essay attribute and the array attribute. So, the essay attribute grammar is characterized by having no inherited attributes in it, but only the synthesized attributes. So, the inherited attributes must be passed down from the parents node to the child nodes of the abstract syntax tree. So how does it work is basically when we build a node tree, so the attributes are made in the form such that the parent nodes must have the abstract value and as compared to the child nodes during the semantic analysis of the parsing process. And it is also known as the bottom-up parsing process, in which when the parsing takes place, it starts from the top and it goes down from top to bottom, and then it covers the leaves from top to the root and then the leaves. So it has, as attribute grammars can be cooperated community in both top down and bottom up parsing, but in this one the top down parsing is a little bit more difficult and complex as compared to the bottom up parsing. So generally people prefer to parse in a bottom up way. So let me explain you with an example, a small example in which it's given as the b tends to val of b when the value is given as 0 and the length is given. The length of L is equal to length of L1 plus 1. So when we make a tree, before that we need to have a stack table. So in a stack table you have, I forgot to mention you about the stack table, in which the values which are present are stacked up with the help of BU parsing, and a parallel stack is created in such a way that the input can be separated differentially between the variables, exponential, and the numericals, the numbers. So yeah, we have made a stack in which $11 B11 L11 L11 11 dash 11 L32 and LN32 are made in a stack. So how does the stack came? We have an input of shift red 2. So when $1 is inserted in the stack, so we go down, we have red 2. So when we come to red 2, we have the node of 2. The next thing is we have to find the B. For the finding of B, we'll go down. We have the next tag as L11. So we put in the third node and then we will find L. We found B, we found L, we have the two nodes, then we go down. Then we shift to another node. Shift to another node in which L11 dash is present. So we have to evaluate in such a way that we should have a reduced value of each. So evaluation takes place as a process of reduction, and so while the process of reduction takes place, we have to make sure that each node has a child value, because the child value are inherited from the parents. The child attributes are inherited from parent attributes. So in this one, the child of 2 is L32, which is the fifth one. So we have mentioned this as at 5, and then afterwards we have to find the n. And in the stack we have n32. If we found the n32, then it is accepted. So basically the whole string is accepted. This can be done without the help of the stack table, also with the help of the parsing method, which is the bottom up parsing. So in the bottom up parsing method we generally parse. We have the inherited value. Suppose example, we have a grammar G which has the V node, E attribute, and for first call and follow up of each process. So we can do by help of the shifting method, in which we can make the nodes, and in a by traversal method we can just traverse the method from bottom to top. Thank you.